Good morning, students. In this session, we are going to discuss about biomedical waste management, green chemistry, and its principles. The definition of biomedical waste includes anything tested or used on an individual or any trash from biological experiments or medical waste, generated from waste generated by healthcare facility, research facility laboratories, and hazardous healthcare waste, that is around 85% waste in non-infectious and 10% are infectious and 5% are hazardous. The steps to manage biomedical waste comprises of characterization, quantification, segregation, storage, treatment, and disposal. Apart from this, if you have any other idea regarding the disposal of biomedical waste, please give your perception and ideas. And the segregation of waste can be categorized into 4 categories, that is by color coding and types of container waste category treatment option. And in color coding, it includes yellow, red, black. And the type of containers are plastic bags, disinfectant container, plastic bags. And the treatment options are incineration, deep burial, autoclaving, microwaving, and disposal in secure landfill. Biomedical waste and technologies. Technology is only a fraction of the solution. Major components of waste management are segregation of waste, waste minimization, reducing the use of hazardous substance or process waste audit. Approved treatment methods includes autoclave, chemical disinfection, hydroclave, microwave, incineration, any other technology after CP/CV approval. And the exposure to hazardous healthcare waste can result in infection, genotoxicity, cytotoxicity, chemical toxicity, radioactive hazards, physical injuries, public sensitivity. And the further steps includes in biomedical waste are survey of waste generated, segregation of hospital waste, collection and categorization of waste, storage of waste not beyond 24 hours, transportation of waste, treatment of waste. Let us prove that we are eco-friendly to make others share their austerity and become micro-friendly. Source reduction, waste to lessen the amount of material. Number 1 is segregation, keeping non-infectious waste out of the infectious waste stream. Minimization, reduce or eliminate waste at the source. Engineering controls includes methods to reduce quantity of waste. The conclusion of the biomedical waste management involves refuse disposal cannot be solved without public education. Individual participation is required. Municipality and government should pay importance to disposal of waste economically. Thus, educating and motivating oneself first is important and then teach others about it. In the next topic, we are going to discuss about green chemistry and its principles. And the objectives of the green chemistry is to conceptualize the sustainability, to understand how to apply the concept in our research field of interest, aiming to save our planet, to think prospectively about how to change our education subjects to be sustainable learning tools by investigating examples of green chemistry applications relevant to students, to understand the important role of green chemistry and how to deal with it in our practical life. And the performance objectives includes to understand the importance of green chemistry for sustainability, to design and interpret greener route to the traditional chemical reaction, to learn how to teach green chemistry as a lab course. And here we provide a link regarding the principles of green chemistry. Sustainability is nothing but meeting the ends of present generation without compromising the needs of future. In general, what is green chemistry? It's the technologies of invention, design and application of chemical products and process to reduce or to eliminate the use and generation of hazardous substances and where possible utilize renewable raw materials. As human beings, we are part of environment. The way in which we interact with our environment influences the quality of our life. Green chemistry is also called as benign chemistry or clean chemistry. It refers to the field of chemistry dealing with synthesis, processing, use of chemicals that reduce risk to humans and impact on the environment. And green chemistry education is quite important to sustain the development of new education materials. And the prime things that we are going to discuss about green chemistry is how to reduce waste, how to reduce material, how to reduce hazard, how to reduce risk, how to reduce energy, and how to reduce the cost. And here we have highlighted the 12 principles of green chemistry that involves prevent waste, maximize atom economy, less hazard chemical synthesis, safer chemical and products, avoid chemical derivatives, use renewable feedstock, increase energy efficiency, safer solvent and reaction condition, use catalysts, design chemical and products to degrade after use, analyze in real time to prevent pollution, minimize potential for accidents. And these are the basic 5 principles of green chemistry: prevent waste, design safer chemical and products, design less hazards, use renewable feedstock, use catalysts, non-stoichiometric reagents. And here we provide a link for your reference. Please have a look on that. And these are all the other principles of green chemistry. For example, if a chemical reaction is of time, suppose the reactant is A and B and the product what we are getting is P plus W, you have to find some alternative for A and B to avoid the W so that we can eliminate the byproducts, thereby increasing the output of the required product. And green chemistry education is quite important for the future generation to know more about the raw materials, cost, and the process, effective process or innovative process. So it's all about the future generation. And green chemistry has come a long way since its birth in 1991, growing from small grassroots idea into a new approach to scientifically basic raw material production. All over the world, governments and industries are working in green chemistry to transform the economy into sustainable enterprises. Thank you.